Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day everyone. So today is our asynchronous lecture for week number 10 if I'm not mistaken. Right, okay, so we'll continue with our chapter 4. So today is going to be part 2. Okay, this video is part 2. Definite integral. Okay, definite integral. We'll proceed to the next subtopic, definite integral. Okay, so this is basically tak ada apa lah. It's just some formulas, okay, to show to you. Okay, as you can see here, the integration, normally when we want to solve integration, okay, it come out in this form, okay, where integration, this is a symbol for integration, from A to B, meaning that it shows what is the lower limit of the integration that you are going to solve up to upper limit. Okay, fx is the function that you are going to integrate, dx with respect to the what variable. Kalau macam ni maknanya with respect to x. Okay, so as what we have discussed during our synchronous class last week, okay, integration ni maksudnya is we are looking for area under the curve of fx kat sini. Alright, so it's different from the differentiation. Differentiation is the slope of the curve kan. Dia punya rate of change tu. Katakanlah kita ada curve macam ni, fx. Alright, this is our fx. So let's say the question asks fx respect to dx from A to B. So maknanya kat sini, okay, let's say x to A tu kat sini, B kat sini. We are looking for area under the curve for this function fx. Okay, so that is very crucial kalau kita nak come out with this value. Okay, kalau macam ni maknanya kita akan dapat a value berapa, 20, 30, 50, okay, for example. So it's very crucial for us to know what is the lower and upper limit. Okay, so to compute, okay, the final answer for the integration, maksudnya kita gantilah upper limit, okay, fb. Katakanlah kita integrate, kita dapat function fx. Okay, function fx is the hasil of our integration of fx. Kita dapat capital Fs. So to get the value, we substitute with the upper limit. Okay, gantikan x tu dengan b and minus with the value of when it is x is equals to lower limit f a. Alright, okay. So next, okay, there are some order for integration. Okay, ni macam saya tunjuk tadi kan. Okay, so as you can see here, this is integration from A to B, upper limit A, lower limit A, upper limit B. What happen if you do it terbalik? Okay, integration from B to A, sedangkan B tu value dia lagi besar daripada A. Okay, B berada di belah kanan, A belah kiri kan. So maknanya B ni lagi besar lah, katakanlah 7 kat sini 3 perhaps. Okay, so kalau you integrate dari 7 ke 3 instead of 3 ke 7 macam ni, so definitely the answer will be terbalik. So dia akan jadi negatif lah. So this is the backward order of integration. Maksudnya if integration from B to A fx ds, then it's equivalent to integration of negative A to B fx dx. Okay, faham kita tengok gambar ni, you all boleh faham kot. Alright, okay, and then second rule, okay, zero with interval. As I said just now, okay, integration maksudnya dia adalah area under the curve kan, yang sebelum ni kita kata from A to B. Okay, from A to B, dan kita dapatlah area. But if the integration asks you to integrate from A to A itself, tak ada apa daripada A ke A, mana nak ada area, betul tak? Faham tak? It's just a line from A to A. There's no width, dia tak ada lebar dia kan. Area kan kita cari yang chapter apa ni, we discuss during our synchronous class. We estimate to area under the curve, we say that is equals to delta x times with the width y kan. Okay, so kalau with ni tak ada, dia tak jadi area, so it's just a line like this. So zero, what we call it as zero width interval, so the integration would be 0, definitely 0. Tak payah nak susah-susah integrate what is fx here, because we know that from a to a, meaning that there won't be they won't result any area. Okay, alright. And then here it is constant multiple. Yang ni saya rasa simple. I will skip this. Okay, you can just have a look on your own. Okay, and this one pun sama je. Okay. Alright. So to sum up the all these rules ni, you boleh tengok daripada properties kat sini lah. Alright. So this is the same as the figure that I've shown to you. Alright. So let's quickly solve example 4 here. Example 4 here, given to you, fx dx, okay, it's already given to you the value. The integration of fx dx from 1 to 4 is equals to -2. From -1 to 1, fx dx is equals to 5. Integration from -1 to 1, gx dx is equals to 7. We want to solve the following question here, a, b, and c, based on the properties of definite integrals here. Okay, kita boleh tengok lah. So yang ni saya rasa simple je. Okay, so yang ni a here, integration from 4 to 1 fx dx. So yang ni maknanya kita boleh make use of the properties that we have. Okay, so saya rasa yang soalan a tadi, we can use this order of integration because okay, same function fx, yang ni pun fx, so yang ni we would say is equals to negative integration of from 1 to 4 fx dx. Dia punya order tu dia complement je lah, so the answer will be negative. We know that integration of fx dx from 1 to 4 is equals to -2, so here the answer is equals to 2. Simple kan? Alright, and then for b, okay, we have this integration of 2fx plus 3gx dx, okay, from -1 to 1. So here you can use few properties from here. We can use constant multiple dengan sum and difference, okay, number 3 and number 4. Alright, so kalau ni, I will break out into 2 terms here, and 2 I may just bring it out from the integration. Okay, so 2 times -1 to 1 fx dx integration plus with 3 times integration from -1 to 1 gx dx. Okay, this is based on the properties that we have discussed just now. So integration from -1 to 1 fx dx, okay, apa dia punya value is equals to 5. Senang sangat. Okay, this one is equals to 5 kan. So here 2 times with 5 plus 3, integration from -1 to 1 gx dx is equals to 7. There you go. So you have 10 plus with 21 is equals to 31. That's it. Okay. Okay, now we proceed to C. Okay, C integration from -1 to 4 fx dx. If we look this, do we have -1 to 4? Okay, directly no kan. Kita ada 1 ke 4 and -1 to 1. Okay, so how can we compute the answer for integration from -1 to 4? Okay, so we'll make use, of course GS ni tak boleh pakai lah, so these two, how to make use of these two? Alright, so kalau you tengok again on the property, we have additivity property. Okay, integration from A to B fx dx plus B to C fx dx. A is equivalent to integration from A to C. Sebab maknanya macam ni, kita tambah 2. Okay, so the same things goes here. So maknanya yang ni, integration from -1 to 4, you can make use of integration from -1 to 1 fx dx plus with integration from 1 to 4 fx dx. Okay, So easily we can get the answer. Integration from fx dx from -1 to 1 is 5, plus with integration from 1 to 4 fx dx is -2. So 5 plus minus 2 will get 3. Okay. Alright. So again, here are list of the indefinite integrals and the total change theorem. Okay, yang ni formula ni from time to time we will get familiar with this lah, because when we frequently use, I'm sure you are aware of all these formulas. Okay, macam yang ni tadi kita dah guna dah. When it's constant, you may bring it out, and then C, integrate constant C dx is equals to C x plus C constant. Itulah sebab dia indefinite. Kita tak ada lower and upper bound. So that's why we plus with C. It's not finite. Okay. So kalau before this differentiation, kita differentiate constant, you get 0. So integrate the anti-derivative kan. So maknanya yang ni sebenarnya C, you integrate constant with respect to dx. As I said just now, C ni constant. So you may bring out C. So apa yang tinggal kat sini? Adakah kosong tinggal kat sini? No, it is actually 1. Okay, dia 1 with respect to dx. And then 1, saya nak you faham konsep dia. 1 ni sebenarnya adalah x power of 0 dx. So we know x power of 0. So you see here, the formula is x, and now for our case here, n is equals to 0. So when you want to solve the integration, maknanya x 0 plus 1 over 1. So you get the answer equals to cx. Kan? Macam yang ni. Okay, so make sure you understand the concept. Yang ni the power beginning of chapter 4. Last week pun we have verified this. And then for 5, okay, remember, when we differentiate an exponential function e to the power of x, you get back e to the power of x, kan? So that's why if you integrate e power of x, you will get back e to the power of x plus c. And ingat tak yang ni? Differentiate ln x dapat apa? Dapat 1 over x, right? Chapter 3. That's why when you integrate 1 over x, you get ln x. You tak boleh nak pakai konsep yang ni, okay, kat sini. You can't use the rules number 4 to solve integration for 1 over x. Kalau macam tu, you will be in trouble. Sebab yang ni, 1 over x ni adalah integration. Kalau you buat naik atas kan, negative 1, x power negative 1 dx. Then you trying to add up the power, negative 1 plus 1. Okay, you will get x power of 0. And then, power tu negative 1 plus 1, kosong Okay, so you will get this. This is not correct. Okay, so 1 over x dx integration, you will get ln x. And this is trigonometric, okay, because we differentiate cos, we differentiate sine, we differentiate cos, we get negative sine. So that's why here, we integrate sine x, we get negative cos x. We differentiate sine, we get cos. So that's why you integrate cos, you dapat sine. Secant square x, okay, equals to tangent x. Because you differentiate tangent, you get secant square x. Cosecant square x, integrate, you get negative cotangent x. Because if you differentiate cotangent x, you dapat negative cosecant square x. And then integrate secant x tangent x, you get secant x. Because when you differentiate secant x, you dapat secant x tangent x. Nampak tak? Kat sini, if you see, do we have what is the integration for tangent x? No. Tak ada kan? It's not in the list here because it's not straightforward. Because if you remember back in chapter 3, what we differentiate, we get tangent x. Cuba ingat balik. Okay, differentiate sine, do we get tangent x? No. Cos, tak. Okay, tangent, you differentiate tangent, you dapat apa? You dapat secant square. Alright, so maknanya why it is not in the list, because none of the function, if you differentiate, you get tangent x. But does it mean that we can't integrate tangent x? No, we can integrate tangent x, but we need a specific technique to solve this. Okay, so harap bersabar, stay tuned. We will discuss about that soon. Alright. Alright, so I think we'll stop here for the first part of the video. Then afterwards we continue with the second part soon.